Okay, here's a good question. Love this question. You'll have one just like this on the test. So it says flight of ball thrown upward and the data's there. And then they say use Desmos graphing calculator to do a quadratic regression on the data, and they want to know what the function is. So what you do to find out the function is down here you tell Desmos to figure out all those values for you. And I typically like to put you to put it in the vertex format. So that's the one shown there. So it's y1, and then instead of equals, we do a tilde, and then a, and then x1 minus h bracket squared, squared, plus k. Okay, so if you do that right, you look at the thing, and it looks like it's following the dots almost perfectly. If I scroll down here, it gives me the values for A, H, and K. Also notice that the correlation coefficient is perfect, and that's not normal. Typically things aren't that close to being 1, but anyway, so they say, what is the function provided by regression? So I have to write it in this form. So let me write it out. So A would be y is equal to, A value there's negative 2.39, negative 2.39, and then bracket x minus h is 2.29, we'll call it, squared, plus k is 12.59, 12.60, call it, 12.60. So that is the function that describes that pattern. And then it says, at what time will the ball hit the ground? So that's that point there. It's like 4 point something. I don't think it'd be 4.5, but what I can do is I can go here and I can tap on that point. So the point when y is equal to 0 is 4.58, call it 4.59. So for B, it would be 4.59. You could solve that by plugging a 0 in for y and then solving that equation, but that's a little bit dicey of an equation to solve. So I typically just have people look at the graph. And then it says, how high does the ball get to, and what time does that happen? Well, that'll be the vertex, right? So the vertex is that top point. Let me tap on it. Okay, right there. So at 2.29, at 2.29 seconds, the height is 12.60. 12.60, I think it was in meters. Okay, so that's how you can read that. Another question I like to do with this, and again, you can use Desmos to do it. You could say, well, when does the graph, or does the ball hit, say, 10 meters, a height of 10 meters? So you can do that very easily with the graph. If you go in there and just here, below the graph, type the line y is equal to whatever height they want, 10. And it puts a line there at 10, and then you can just tap. So at 1.25 seconds, it reaches 10, and on the way down at 3.34 seconds, it also reaches 10. Another question I could ask is, say, like it hits the ground at 4.59 seconds, so how about 3 seconds? So how high is the ball at 3 seconds? And you could put a 3 in for x, I'll show you that in a sec, or you could just go x equals 3. And there's the line at 3, and so wherever it crosses my line, that'll be the height. So at a height of 11 or the ball is at a height of 11.4 meters after 3 seconds. Another way you could have done that one is plugged a 3 in right there. You plug a 3 in there and then figure that out, and it should give you a number that's very close to that. All right, hopefully that helps you with that regression, quadratic regression.